Welcome to video 12, our last video for this chapter. And we are going to be talking about the withdrawal reflex. And this is one we're all familiar with because we've all done things that have hurt. And this again is for protection. So you can see that purpose of reflexes really is protection in all of these. So if we just take a general overview, you can see here we have a stimulus and a pain receptor. So pain receptors detect that there's something wrong. In this case, it looks like the person is stepping on a tack, which in your bare feet is going to hurt. So here we have the hamstring and the quadriceps again. You can see that we have our four parts. And up here you can see that we have an excitatory interneuron. And then right here we have divergence again, but there's no convergence. So again, this one cannot be overridden, but the brain is aware, and of course we're going to see pain here as a response. So our first step, if we look at number one over here, is the stepping of the tack. So pain receptors cause an AP in the sensory neuron. And then that message travels along the sensory neuron into the spinal cord via the dorsal root. Then we have divergence. So two things. We go to the brain for awareness. So we interpret that as that hurts. And then an excitatory interneuron. So that excitatory interneuron is just a relay, and it synapses with the motor neuron and generates an action potential. That action potential travels along the motor neuron and causes the muscle to contract. So what happens down here is the foot gets lifted up. So by flexing this, it moves the foot up and the whole leg up, and you are moving away from that. So this could also be you put your hand down on a hot burner and it's almost instantaneous how fast this reflex does, because it doesn't have to travel up through the brain, wait for the brain to respond, and then come back down. It all happens within the spinal cord. So those couple milliseconds can mean a lot of difference.